Imagine a world where energy is virtually limitless, clean, and inexpensive, simply created by fusing atoms at room temperature. Sounds incredible, right? This dream captivated the scientific community and the public alike, leading to one of the most astonishing scientific announcements in recent history. The first announcements of what was called cold fusion became huge because they promised an energy revolution with seemingly simple, tabletop experiments. Two scientists, Stanley Pons and Martin Fleischmann, claim to have achieved nuclear fusion at room temperature using a basic setup, a feat previously thought only possible in extreme conditions like those found in the sun or inside massive, expensive reactors. This incredible claim, if true, would have solved the world's energy crisis overnight, sparking immense excitement and widespread media attention. The primary reason for the immense hype was a combination of extraordinary claims, a desperate global need for new energy sources, and the researchers' decision to go public through a press conference rather than traditional peer review. Nuclear fusion, the process of combining light atomic nuclei to release massive amounts of energy, typically requires temperatures of millions of degrees Celsius. The idea that it could be done with simple electrolysis in a jar, using heavy water and palladium electrodes, defied decades of established physics. This contradiction, coupled with the desire for a cheap energy solution, created a perfect storm for public fascination, even as many scientists expressed deep skepticism. To understand such dramatic announcements, it is helpful to look at how scientific claims are usually verified. Typically, new discoveries are submitted to scientific journals, where they undergo rigorous peer review by other experts in the field. This process involves scrutinizing methods, data, and conclusions to ensure validity and reproducibility. In the case of cold fusion, the initial announcement bypassed this crucial step, going straight to the media, which amplified the claims before they could be properly evaluated by the scientific community. This meant the public heard the exciting news without the necessary scientific caution. The term cold fusion itself is a fascinating example of how language can shape perception, contrasting sharply with hot fusion, which describes the established high-temperature process. The dramatic announcement created a global race, with laboratories worldwide attempting to replicate the results. Many reported initial anomalies, which further fueled the excitement, but ultimately, none could consistently and reliably reproduce the excess heat and nuclear byproducts that would confirm actual fusion. The lack of verifiable neutron or gamma-ray emissions, characteristic of nuclear reactions, eventually led the mainstream scientific community to largely dismiss the claims. Ultimately, the initial cold fusion announcements became huge due to their revolutionary promise, the unconventional way they were introduced to the world, and the powerful human desire for easy solutions to complex problems. This story serves as a powerful reminder of the importance of the scientific method, emphasizing the critical role of peer review and independent replication in validating extraordinary scientific claims before widespread acceptance.